Not all events are unrelated. Events are considered related or non-independent if the outcome of one event affects the probability of another. The classic example here is drawing marbles out of a bag. Consider an example where we have 40 marbles in a bag, 10 of each color, red, blue, yellow, and green. If we want to know the probability of A, then B, we first need to know the probability of A. Let's say that event A is drawing a green marble. Then its probability is 0.25. The probability of drawing a red marble second, event B, then has a probability of 0.256, that is 10 over 39. There are 10 red marbles in the bag out of the remaining 39 marbles. Finally, the probability of drawing A, then a B, is the probability of A multiplied by the probability of B given A, which is the probability that B happened assuming that A happened. This is 10 over 40 multiplied by 10 over 39, which equals 0.064. Mutually exclusive events, as we've already discussed, are those that cannot occur at the same time. For example, drawing a card that is both a spade and a heart, or flipping a coin that is both a head and a tail. If events A and B are mutually exclusive, then the probability of getting A or B is the sum of their individual probabilities. Let's say that the sample space here has 3 possible outcomes, A, B, and C. The probability of getting A, B, or C has to be exactly 1. If A is drawing a heart and B is drawing a spade, both from a well-shuffled standard deck of cards, then probability A is 1/4 and probability B is 1/4. So the probability of A or B, the probability that one or the other of these events happens, is just the sum of their 2 individual probabilities, which is 1/2. Things get a little bit more complicated when events are not mutually exclusive. This happens when events can occur simultaneously. That is, for example, drawing a spade and drawing a jack. If 2 events can happen simultaneously, then they are not mutually exclusive. In this case, if we want to know the probability of A or B, it's the sum of their individual probabilities minus the probability that both happen at the same time. In mutually exclusive events, the probability of things happening simultaneously is 0. The basic idea is that because the events can happen simultaneously, we have to acknowledge the probability of double counting a particular event. The jack of spades counts both for a jack and for a spade. It contributes to both counts, so we have to subtract the probability of both events happening simultaneously. The probability of drawing a spade is 13 over 52, which is 1/4. And the probability of drawing a jack is 4 over 52. The probability of getting the jack of spades, that is a jack and a spade, is 1/52. And when we put it all together, we get the probability of a jack or a spade is 13 over 52 plus 4 over 52 minus 1/52, which all works out to around 0.3.